We have to find carrier density in intrinsic semiconductor. As you are aware that in intrinsic semiconductor, number of electrons n is equals to number of holes, and that is equals to carrier density. This n suffix I is called the carrier density. In the last lecture, we have found the equation for number of electrons, that is n is equals to nc e raised to minus of Ec minus Ef upon Kt. In this equation, the value of Nc is equals to 2 into bracket 2 pi Me star Kt upon S square, and this bracket raised to 3 by 2. Also, we have number of holes is equals to Nv e raised to minus of Ef minus Ev by Kt, and in this case Nv is equals to 2 into bracket 2 pi mh star Kt upon S square raised to 3 by 2. So we already derived these equations. Then by law of mass action, N into P is equals to Ni square. Let us substitute in this equation the values of N and P. So N is equals to Nc e raised to minus of Ec minus Ef upon Kt into Nv e raised to minus of Ef minus Ev upon Kt, and that is equals to Ni square. Let us simplify this. Ni square is equals to Nc into Nv into e raised to minus of Ec minus Ev upon Kt. However, we know that we have Ec minus Ev is equals to Eg, that is band gap. In this, Ec is the bottom energy level in the conduction band, and Ev is topmost energy level in the valence band. The difference between them is the band gap. So let us substitute the values of this Ec minus Ev in the above equation. Then we get Ni square equals to Nc Nv e raised to minus of Eg upon Kt. Take square root on both sides. Then we get Ni is equals to square root of Nc into Nv into e raised to minus of Eg upon twice Kt. Now in this equation, substitute the values of Nc and Nv. We know that this is the value of Nc and this is the value of Nv. Let us substitute this in this equation and rewrite it. So Ni is equals to square root of Nc is 2 into bracket 2 pi me star kt upon h square raised to 3 by 2 into Nv, which is 2 into square bracket 2 pi mh star kt upon h square bracket raised to 3 by 2. Then e raised to minus of eg upon twice kt. Let us simplify this further. So here is a 2, here is a 2. Let's take 2 outside. Then here is 2 pi k. This is 2 pi k by s square raised to 3 by 2. It is twice. So you can take it out. 2 pi k upon h square raised to 3 by 2. Then in the square bracket, me star mh star raised to 3 by 2, and then this t raised to 3 by 2. This is t and this t. We are taking it out of square root into e raised to minus of eg upon twice kt. Now in this equation, this term is constant, and after substitution of their values, we get 4.81 into 10 raised to 21 into t raised to 3 by 2 into e raised to minus of eg upon twice kt. So using this equation, you can find carrier density Ni.